Here's a section through the part that I'm dealing with, this titanium piece. And remember in the previous video we made this boring bar in a previous video about this part. And now we need another tool. We also made this undercut tool here there's an undercut here, and there's also one over here into that groove. But we still need one more tool. We need this tool to cut these chamfers on the between the bore and the grooves. All these are all 30-degree chamfers. So that's what this video is going to be about, making this this tool here in order to do those chamfers. So here's the drawing I printed out off the CAD software of the tool I designed that I showed you earlier. And we're going to program this on the Star grinder here behind me. So we have to define some profiles. Actually, what we're going to do is define a separate profile for this cutting edge and this cutting edge, and then a profile to grind this neck down. This is starting at a 3/4 inch diameter blank, as you see here, and 5 inches long. Let's start a new model here real quick. This program here that you're seeing right now I was making this tool here for a customer, a local customer. They wanted to do some kind of a face groove like thing in the bottom of a bore, and this is the tool. So that's what this program, in fact I could probably show you the simulation of it here. Might be interesting. Zoom in on it a little bit here. So this is the tool I just showed you. This is the simulation for it. There's the fluting wheel. The wheel that's highlighted on these things in color is the wheel that's in grinding. It shows you kind of a ghost view of the other wheels as well, that if there's more than one wheel on the wheel pack, that is. So that's the simulation of that particular tool. This is kind of a complex tool to grind here. You can see the geometry of it is, because of this recess on the face of it, is kind of complex. This tool that we're going to program here is much more simpler than that. Anyway, that's the simulation of this tool. I'm going to save this, and then I'm going to start a new, well actually what I'm going to do is up here they have this little icon, you can select it, and I'm going to make a form cutter, and then I'm going to make a new one, and I'm going to manufacture, not resharpen it, here. And for every form tool there has to be an initial form, at least one form. So we're going to program, or actually we're going to draw, I should say, the profile that I was talking about on the drawing here. We're going to just draw this profile first. So this thing is kind of reversed here, and the Y is going to be in the upward direction and the X goes this way. So it's as if I flip this over really, on this, X being this way and Y being this way. In reality this ends up being like the Z-axis on the machine, but this is just the way this program works. So we have to make a line, and we've got to start it, and looking at the drawing here again, 550 divided by 2, because this is radius on this thing. So it's going to be well, it's going to start at 0 on X, right? It's going to be 0.225, and then we got to go to the end point, which is going to be .1732 tab, and it's got a 30-degree angle. So we're going to go 0.375, half of 3/8. I must have the start point. That doesn't look like a 30-degree angle, does it? What did I enter in wrong? Half of 550 is 0.275, right? So half of 550 thousandths diameter is 0.275, and 0 is our start point. Okay, we're going to call that the first form, is what they call it on this thing. Okay, and we're going to say okay, and we're going to make another form, and we're going to do the backs. We're going to do the back side of this form. So it's going to start at 0.1732. So 0.1732 and 0.375, right, out there. And then we're going to go to the ending point, and you can enter a length and an angle here, but I know what the coordinates are of this. The coordinates are 0.3464, 0.3464, and 0.275 again, like the other one. We're going to say okay. So that's the back side, our back chamfer cutting edge, if you will. Okay, and then okay for that. These here, you can kind of offset these profiles in the axial direction or the radial direction, or in the circular rotational direction in on the A-axis rotation. So we can kind of see the beginning of our form right here. We've got the first one and the second one. Now I want to add another one, and this is just going to be for the purpose of grinding away this neck down area right here. And you'll see why later. It's not gonna, although it's gonna think there's cutting edges on here initially when we kind of process this into the program, the initial program, what would you call it? Fields, I guess. But we're going to delete those because we don't need cutting edges on there, of course. We just want that for the purpose of cylindrical grinding, if you will, off that area. So the X is going to be, the end of this is 0.3464, 0.3464, and the Y is going to be 0.275 again, which you can see that little start point right there maybe. And then we're going to go to the ending point, and we're going to give XY coordinates again of 2.3199. 2.3199. Okay. So that's that one. Let's zoom back a little bit on that. I'm going to check that again. Make sure it's not too long. Yeah, that's right. Okay. So we're going to go okay with that. So we got these three forms. You could do this all in one form, but I have found that it's better to do it in two different forms. It makes it easier to actually get it a little bit nicer when you grind it. Next, we've got to have a relief angle, and we're going to need relief angles on Form A and Form B. Form C, we don't really need them because we're not going to be grinding cutting edges on there. Form C, as you remember, is just for the neck. And then we got to have at least one helix. I'm going to make this straight flute tool. I'm going to make it 4 flutes. And the length was, this isn't really that critical, but it has to do with how long you're going to grind the flutes. But I'm just going to make it for right now 0.3464, the length of the last, this length right here. I can adjust the flute lengths anything I want in the flute grinding part of the program. Straight, right hand on form A is good. Form A and form B are actually going to be in the same place, but it needs at least one of these forms to know where to put the flutes, if you will. Now you could, on this software, you can unevenly, irregular pitch, I guess you'd call it. Well, that's what they say here. And you can put the flutes at uneven angles and things, but I'm not going to bother with that on this tool. I'm just going to make a plain 4-flute tool in this case. So we would say OK. Then the next is the tip. If you want to have a cutting edges on the tip of the tool like an end mill has, but we're not going to need that in this tool. We don't care about that. It's just a chamfering tool on the side. So we'll go next. No coolant hole, carbide, and the blank here is, it's kind of defined this blank the way it thinks it's going to be. It's pretty close. It's got a 5-inch long blank. I'm going to leave that, the rest of it alone, the default values. Now I think I stuck this out. We'll see if this is long enough. I can always change this later. 2.630. I think I stuck it out 2 5/8 from the collet, and I happen to know that the collet chuck and the collets are 5.8 inches long, and the diameter of that is, let's just say it's 800 thousandths. So that's the basic representation of that. This can all be changed later if we find out we have a collision with the collet chuck. Okay, relief angle. See, it kind of makes a basic program here for you, and you got to assign grinding wheels and everything to this. Which let's see, what are we going to use for this to grind this thing with? I think we're going to use. First of all, we're going to insert a operation that we're going to just cut the end off flat. I usually do this just, I'm going to use this grinding wheel for that. I usually do this just so I'm sure where the end of this is. And we're going to go 0.4. We're going to go minus 0.4. And we're not going to retract along the path. No division. No division means it's not going to do it every flute. It's just going to do it one time across the face. And we're going to leave that. That's no, we're going to leave 0. We don't need any stock on there. We want it ground flush. I'm going to turn the. Anytime you add or change a grinding wheel, you got to specify the coolant nozzles it's going to use. So we're going to flute. How are we going to do this now? I got to think about this a second. I could flute with that same grinding wheel that I'm cutting the end off flat. I'm going to use that same wheel later to grind the I think I'm going to do this. I think I'm going to use this here. This grinding wheel is on a wheel pack with 3 wheels on it to flute with, and for this up here somewhere I'm going to use that cup wheel to grind the front relief angles, and then I'm going to use this. I think I'm going to use profile, 3M profile. Yeah, that might work. I'm going to use this grinding wheel to grind the back cutting edges, and these 2 we're not going to need. Now I'm going to put the coolant valves on each wheel before I forget to do this. I can always do this later too, doesn't matter, but I'll do it right now. See, when it shows this little icon here, it says there's no coolant specified, and you usually don't want to grind anything on this grinder with no coolant on. Okay, that's the basic program. Now I'm going to go in here and I'm going to extend the flute length on the rear. I'm going to try 0.7 or no 0.5, excuse me, to begin with. I'm going to check these values here, the core. I'm just going to see what that looks like. So we're going to run the simulation just like this for right now. Oh, I got to change something here. I see. Forgot. This, I can use helix angle there, but I got to have relief B on profile B. And relief B on that profile as well. I'm going to change this to that, and that to that. On here, I'm going to change this. But I want to do face grinding with that wheel, 10-degree angle. I'm going to go minus, this is a 30-degree angle slope, so I'm going to go minus, say about 20 degrees. Let's try that. I want a little bit of an angle on the grinding wheel. Change it to here and go minus 20. There's all kinds of different things you can do here on a relief, on a form tool type of profile, and you can actually specify the range. In fact, I'm going to want to extend these. Should have done that before on the other ones too. I want to extend that one. I'm going to want to extend this one. You can see it if I zoom back a little bit. You can see these little extra extensions it's put on the profile. And on this one, I'm going to actually extend the one up here on this side 30, but I'm going to only extend this one about 10 because this is going up into my neck area of the tool. And also I might want to do a little bit of disengagement, change the disengagement on this too. I may want to grind, while I got this tool here, I could insert, and on form C I can do a plunge grinding profile. This will be the neck of the tool, and I select the same grinding wheel as I'm using here, so I don't have to change grinding wheels too much here. And stock amount 0. I don't want to leave any stock on that. And swivel axis 15 degrees. The wheel has a 15-degree angle. And the range, displacement per cut, we'll try 1/4 of an inch to begin with. That's going to be the amount it steps over every cut. I'm not sure. I might have to move this up on the end here a little bit. We'll see how that looks on the cutting end of the tool, if you will. This I might have to rough off too with that grinding wheel. I'm just going to leave it like that for right now, just to see what we got going here. So that's the necking down. I'm going to have to adjust the feeds and speeds kind of on all of this still. And I might want to rough in. Oh, see, this one's grinding on the wrong side of the wheel, so we got to change that. Which is going to be over here, grinding position, grinds on the inner side of the wheel, and as well as this one, both of those. Let's look at the simulation again. See, because it's totally grounded away. I may want to try to rough off some of this material because I don't want my real sharp pointed wheel grinding that off. And I might want to reduce the core diameter here too, it looks like. It doesn't look too bad, except I don't like, see that our flute is not going far enough up the, see how the side of the back of the flute is kind of tapered. I don't want that, but it's getting close there. Now I probably want to grind a chamfer up here, but I might have to extend the tool out a little further out of the collet chuck to do that. Let's go back further with the flutes. See, these are the kind of things that you I'm going to reduce the core to 0.25 to there. You can play with the geometry and everything of these. If you have you can put flute wash out on the end. I don't think, well, let me put that on the end. Let's see how that looks. It might help a little bit too. I don't like to change too many parameters at once. Otherwise you can't remember exactly everything you did. Okay. I didn't like the way that, I don't like the width of these lands. I'm going to reduce them. I didn't like the way, I thought I had face grinding. Oh, I didn't put it on both of these. I put it on this one. Okay. That. I'm going to go up here to my relief angles, or my relief definition, if you will. And I'm going to put 0.015 for the if you have, I only have 2 lands on here, but if you have multiple lands, then you have to do this second one. But the second one doesn't matter if you only have one primary land like this, if you will. The land width on the primary cutting edges. So let's just see. Formerly, these wheel change positions, grinding change position. When I'm using the wheel in a face, see, it's going to retract too far this direction in the radial direction, over travel the x-axis. So I'm going to put 0.75. Let's try that. And for some reason it didn't initially give it on this one, but okay, let's see how that looks. Larger than the travel limit. The position is larger than the travel. Form A, relief 1. Wait a minute, let me look at this. What did I do here? Minus 10 degrees. Well, this was 20 degrees, right? Oh no, minus 20 degrees. I just didn't enter that in correctly. See, so this is what you go through. You kind of make changes, run the simulation until you get this picture to look the way you want. That's basically what all there is to it. But there is a lot of different settings you can make, as you can see already. See, I don't really want to grind all that meat off with that delicate grinding wheel, if you will. And I might want to even reduce this core a little bit more. See, I'm hitting in here with my grinding wheel that's necking this down, so I might want to move that out a little bit. I'll just make these little changes. Let's move that out 30 thousandths, like that. Make these little changes one at a time. because like I say, I think I'm going to actually make two changes here. I'm going to do this core. I'm going to go down to 0.200. See what that looks like. It might be too much though. I'm going to put another profile in here to take this grinding wheel and rough off some of this stock and this. I actually need to draw the blank the way it really is. Okay, that looks better. I'm going to extend the back of this a little bit more up in. See how I've got this little ridge here? I'm going to extend the back of that a little more up into the neck down area. I'm going to also redefine this over here. This is end stock amount. We'll put 30 and no stock on the diameter of the blank. This is going to make it look like a cylindrical blank like it really is. And on these, the range. No, that's the wrong one. It's this backside. The range, I'm going to go also 30 thousandths into the. Might be too much. Let's see what that looks like. So you're going to see the blanks different. It's going to ask me to, if I want to update it. You see now it looks more like it really does. Right now I just want to verify that I've got the basic program correct. I'm gonna put these angle grinds in here with this wheel after I get things the way I like it here. So I don't have to take that big chunk off with the more delicate wheels. So that looks pretty good. I'm kind of happy with the way that's starting to look. So now let me think about how to I need to put a profile to the plunge grinding. Let's do it after that. Insert a manual grinding path. Here. And this is a little bit. We'll put that same grinding wheel that I'm using above. Depends on what side of the grinding wheel I'm grinding on here. Which in fact, let's see, I'm going to be grinding on the front for this side. So I'm going to tip this thing. I'm going to say negative 75 degrees. That's the y-axis rotation is really the b-axis. I know the y, they call it y is vertical, it goes up and down, but the rotation, if you have it on a rotation, which is what this is saying here, it's going to rotate that. I believe negative 75 is going to be all right. We're going to say, we're going to come up minus 0.5. Everything in front of the Z normally on a CNC machine is in the plus direction, but on this programming of this, it's in the minus direction. It's kind of like the Mazak is the same way. Cross vertical, it doesn't matter. That's going to be up and down. We want it centered on the part. Cross is going to be the in essence the x-axis, and we're going to say well, actually I'm thinking about the way I'm going to do this. Point. What? You got more? Those were the older ones on the 309 piece order. Okay, 3/8. I'm going to try to just grind straight in with this one. So I could probably start here minus 0.1. I could start closer than that. And I'm going to move into this something a little short of this dimension here. So we got this wheel, it's going to be on this side, it's going to be tipped like this, but it already has a 15-degree angle on it. Well, actually, I've got this totally wrong. So this would be minus 90. No, I think I do have it right. Minus 90 plus 15. 90 minus 15, it's 75. Yeah, that's right. I think I got that right. It's either minus or plus. I get confused sometimes with this. And we're gonna just feed straight in to 100. We're gonna go a little less than 100 and, well, yeah, let's just go 173. We might have to adjust this Y dimension. Well, actually, I'm going to go to 0. I'm going to feed that a little bit faster. We're going to leave it at 1 for right now. Then we're going to go to minus 0.173. And here we're going to rotate 360 degrees doing it. And then we're going to stay there and rotate another 360. This is in the incremental mode here, so when I go back here, it's going to be 720. So that just kind of cleans it off, because right now it's spiraled in, and then it's got to rotate another full revolution to kind of clean it off into a cone. And then we're going to move back to minus 0.5. See, I did this wrong here, 0.173. These have to be positive. I get confused a lot of times when you run different machines. And we're going to go 10 times the feed factor there. This, we're going to have to see what the load looks like. I have to adjust all these loads. Just see what that looks like to begin with. We're going to run the first operation, which is facing it off. Next operation is doing the neck. This neck doesn't really have to have a good finish or anything, it's just clearance. Okay, now I'm going to step up to this. See, we're coming up here. We're obviously on the wrong side of X. See how we're opposite to where we want? So I got to go back here. See, I get confused about these sometimes. I can jump back and forth between incremental and absolute, and it kind of get those all entered in at once. I can actually save this so I don't have to keep rerunning this graphics here. So I'm going to save this as the tool blank right here when it finishes this. I'm going to stop and I'm going to save that. Then when I can go back, I can just rerun this by unchecking those. So we're going to step into this here. Now you see I don't have to rerun those. It's got the blank already. Okay. That doesn't look too bad, except that it's going to be doing it 4 times for every 4 flutes, because I forgot to do this. Over here, division, I want to have a separate division of just 1 time. Okay. So I think that's and down here at the bottom of the screen it shows me kind of my load, but it's kind of hard to tell right now until I run the whole program to see what this load down here is in relation to the rest of it. So now I have to do this side of this thing, and gotta think about how I'm going to do that here. I'd like to do it with this same grinding wheel. And I think I can. Let me think about this. Okay, so I'm going to do another manual grinding path. Insert that. And on the Same grinding wheel, except now I want to tip this thing minus, it's going to be a 90 plus 45, minus 135. Let's see if we can do that. And we're still going to grind on the front of the wheel, but we have to come around the part this time, so we're going to minus 0.5. We're going to start at 0.5. Well, no, we don't have to be that far away. We can be half of this, 3.450, we'll say. And we're going to go to minus, or plus, in this case, 346. 346. This is just a rough off some stock. We're not going to worry too much about. And we're going to feed that kind of fast going forward. And then we're going to come into 0.375. It's just, and then we're going to go to 0.275 was half the size, so we're going to 0.275. We might have to adjust that a little bit. And let's make a revolution coming down in there like that. And then we're going to go stay there, make another revolution. And then we're going to come back out. These all have to be minuses though, don't they? To minus 0.5. I'm going to adjust feed rates and everything later. I just want to make sure I got this right. Let's just see if it likes that. So start. We're going to do that operation. That looked sort of alright. We got to grind the whole tool to see if that is alright. And then we should be able to come in here. Oh, it's liking it on this side. So I'm going to be, I think my minuses are going to be wrong here. Not too bad. Okay. Doesn't look too bad. I might have to add stock to that. And you see it's doing it every 4 flutes because, again, I forgot to check that right here on the division. Okay. Let's grind the whole tool here and see what it looks like now. If we've left enough stock here, we'll see it. If we haven't, see if it cleans up. It looked like it did alright. So the only other thing, I'm going to want to grind a chamfer up here on this, just for a little bit of extra clearance and everything. So let me add that while I'm doing this. Insert, and I want to do another manual grinding path. Same wheel. And this is going to be very similar to the first one. So it's going to be minus 75 as far as the angle goes. Points are going to be, I'm going to start here at minus 0.5 in front of the part. And minus 0.5. We're going to go to, what was it? The end of that is 2.319. We'll go to 2.3, and also at minus 0.5. 10 times the feed rate. And we're going to come down to minus 0.375. And that might be, well, we'll try that. Might be colliding with the stock right there. And then, actually we're going to be grinding with the back of the wheel in this case. so that might be alright. And then we're going to go to minus 0.275. Might have to change these minuses to pluses because of we're grinding with the back of the wheel. We're going to rotate it around once, and then we're going to go 720 and rotate around again. That should be, yes. And then we're going to come back out minus 0.5, and we're going to do that at a high feed rate. Okay. But we're going to be grinding with the back of the wheel here. Grinding position, grinds on the inside, division only one time. Maybe. I think I might have something backwards there. Yeah. A lot of times when you reverse the face of the wheel, you got to change this angle to positive. I still might be on the wrong side of the deal too. Operation there. Operation there. Kind of looking at it. Oddball here. Now let's see what happens here. Yeah, see, I'm on the wrong side of the part because when you change the minus, it's going to be positives on these 0.5. We're going to see what it looks like. I don't want it to, I'd rather leave a little bit of a yeah, let's step into this again here. I'd rather leave a little bit of a step in there than to grind into the shank. See, it's too deep. For some reason, this always kind of ends up this way. It's kind of hard to get this to blend to the shank real nicely. So we can transform this actually, which is the easiest thing to do. So we got to add let's go, but we want to shift it longitudinally. I think it's going to be minus 0.030. Let's try that, see. I don't know if I went the right way with that. Sometimes those shift things are opposite of the regular programming. Now see, now that looks sort of decent. Maybe a little bit more. I'd rather there be a little bit of a step here than this little ridge sticking out like that. So let's go minus 0.040 on that. And from past experience, well, let's see what that does. Okay, we'll try it on one. Shows it's not going to be hitting the collet, but it's awfully close to it. I think we're going to extend the tool out a little further. So that's basically all there is to it. I might, but I'm noticing down here the feed rate. See, this fluting cycle is loading, taking a lot of load compared to the other cycles. So what I might want to do is reduce the feed rate on that, which is going to be this, and I'll reduce it down to 2 inches, and we'll look at it again here. See, it gives these loads, these load rates, or grinding load, if you will, are kind of in relation to each other. It's kind of a little hard to tell. See, that's better. When it finishes the whole thing, it'll show it's kind of a little hard to tell what this means in a way, because see, there's certain lines here, which is volume of material being removed. And this is the what you can in effect call the spindle load on here. And although it says like 90% here, it's really not that. It's in relation to the other grinding cycles here. So kind of got to interpret this a certain way. But the thing is to look for is any big huge spikes in this. Let me run the whole thing because I'm not running these two. And I'll start from the beginning because we might have something else that has a big spike to it that we're not seeing yet because of this OD necking down cycle. Let's see what it looks like in relation to the rest of them. And we'll see the whole thing now. So you now see this this cutting off flat thing. It's got a fairly good spike. It might be all right. And this is the first plunge of the this wheel in here. So you could, if I position this, like I can kind of see. See, it's when it plunges in, it's peaking there, and then it tapers off a lot. So what I could do is increase the roll off rate of this plunge grinding. The plunge speed, if I leave that the same but increase this, let's increase it to 2 and see how that looks. Now we're getting a lot more material removal in relation to time, if you will. And it might do that. You have to just kind of be ready with the feed override on this. In the beginning, and then you can adjust your feed rates in your program. Although these two cuts are kind of a little bit strong. I might reduce this to 2.5, and I'm going to reduce this plunge in amount 0.25. I'm going to leave the roll off the same. So you just kind of run this over and over again. Okay, the facing or the cutting off flat looks fine now. And usually I don't like to run these, it comes up with some pretty, well, these aren't too bad. I like to reduce these feed rates a little bit on the cutting edges. It leaves a better finish on the cutting edges. This is the secondary relief here, but this is the cutting edge. 0.5. What did I have that at? Yeah. And then we can kind of do a time study here. Okay, we know that. Well, that might still be all right. 32 minutes to grind the tool. It'll really take longer than that. Particularly if you have to rerun anything. Although this is not too critical. This tool, I can adjust the offsets on the machine when I'm running it to compensate for any differences in where this tip is actually. pretty happy with that. I think that's going to work right there. So that's what that's what there is to programming on this thing. And now I just got to grind the tool and see how it comes out. Here's the result after just grinding the face and the neck down. The first two processes in the program. This particular wheel here, I can't really take video while it's running because there's too much oil and you really can't see anything. This is what it looks like after the next three processes, which were the angles. So this is the chamfer at the end of the neck, and then these were two roughed off these areas so that the next grinding wheels don't have to take so much stock to grind the flutes of the tool, the cutting edges. This little bit here, if you can see that, is left because the grinding wheel here has this radius is bigger than what's specified in the program. Release this wheel. Put this wheel pack in. We're actually going to use this wheel and this wheel. We're not going to use this. This is normally the gashing wheel for a regular end mill. Gashing, the fluting, and the cutting flutes. But we're going to use the first two wheels. Clamp that in the spindle. Take this out. Change the coolant manifold to the proper one. There's a tool, a wheel pack changer on this machine, but I find it just as easy to change these manually as to use it. Here we are after the next grinding processes, which is the fluting, and then the first and second clearance angles on this. You can see them right here. You kind of rotate this. So you can see them on only the front angle here. Here we got to take this grinding wheel out, this pack. And we're going to put this wheel, this is the last wheel, in. Make sure it's clamped. Change the coolant manifold. Back to this one. Grind these back cutting faces. Program, we got to go over to here. First we got to tell it that grinding wheel is in the spindle, which is going to be this one. Okay, then we got to uncheck these and check these two grinding cycles, I guess you call them, for this particular wheel. And then go up here to manufacturing. We're going to use the previously detected values on the probing, so we're not going to reprobe it, and we're just going to say manufactured, go, or whatever. And then it's going to down here we can see it working. We're going to change over to this the machines display, and it's ready to go. I'm going to close the door so we don't get showered with that nasty oil, and push the start buttons. And as you can see, you really can't see anything at all. Finish grind, which would be the back side here. The primary and secondary cutting edges of the back side.